Okay, if you haven't, hello, starting our stream. It's Monday, Moody Monday. This stream was brought to you by Advanced Biomaterial Braiding. Work with polymers, resorbable polymers, metal wires to develop low profile solution. Yeah, I'm not allowed to, I don't even know what it is. I'm not allowed to click on ads displayed on my website. So if you haven't checked bionichaos.com, please go do so. There's a lot of interesting tools. One of the more recent ones is this ECG game. Need to record a video to go at the bottom of the page. But we don't have a good one. We might just do it now. So this tool scrolls different ECG waveforms on the screen, and you're meant to click on which one is abnormal. So if you see some abnormality in the PQRST, click on it. That's how you gain scores. And in the newer version, you play against the robot. I mean, you're not really playing against it. We can collaborate because the robot will actually tell you everything it does. It's a fuzzy logic algorithm looking at positive peaks, negative peaks, raw amplitude, R peak sharpness. So it's essentially halfway through the R peak, looking at the distance on the left and right, and the intervals between P and R and T. So between the different peaks within the PQRST. And we'll give you an abnormality score. So in this case, it's high, meaning it's likely to be abnormal. 0.7, so it's between 0 and 1. 0.5, still 0.55 is still on the high side. 0.7, so you know to click on it. If you just look at that number there, you can kind of collaborate with the robot. And this one has a 0.39 or 0.3, and that's on the lower side, and that tells you it's a normal signal, so do not click on it. And yes, some are harder to detect than others. Can also reduce the noise, then and see how it affects the robot well, and your own performance. Yeah, for normal ECG it goes normal abnormality score goes all the way down to 0.28 something. Yeah, we know for sure the robot doesn't make any mistakes whatsoever when the noise is low like this. And you shouldn't make any mistakes either unless you are not paying attention, which is very common for humans, unfortunately. Now, when we send the noise all the way up, it will start making mistakes. In this case, the false alarm rate will go up. It keeps false alarming, so essentially it's labeling essentially everything as abnormal. You can try and fix the algorithm, but it's actually good for you to see what happens with increased noise, that some of the algorithms, even the fanciest machine learning algorithms, they just stop working. So if you wonder why, this is a good tool to explain that, to show that in, well, real world. But yeah, this is synthetic data, but yeah, we simulate all these possibilities. So you can see the false alarm for the robot keeps going up, and actually now as a human I probably have a chance to match the score of the machine. Yeah, because it will keep making mistakes, so in theory its score should be going down, but it's still going up. Well, right, because yeah, there is a bias in the system. There is 60-40, 60% abnormal and only 40% normal waves coming from. So if you just keep clicking on everything, your score will be going up. Yeah, it is much harder. Yeah, that was normal. Yeah, and it becomes much faster as you gain 50 scores and more. Let's restart it for a sec. Yeah, so that's the default noise level, and we'll be doing some mistakes, no, hopefully not too many. The robot, and if you're paying attention, it should be fairly straightforward with this noise level to detect which waveform is abnormal. Yeah, and as you saw, when it reaches 50 points, the speed increases slightly. And there are videos of me reaching 1000 points. It's crazy fast. So beware. You can obviously go try it out on bionichaos.com. And yes, there are ads running, so apologies in advance. Hopefully you get something relevant. We'll be also adding this hopefully not too annoying tool where you can select the number of particles and the speed of them. And there's this little drum in the middle where each time a particle bounces against it, it will generate a sound. The sound is importantly, actually this description is wrong. I'll have to rewrite it. Yeah, GPT started like hallucinating with code it generated by itself. In terms of, yeah, there's a few incorrect things about it. And yes, we have a disclaimer for GPT-4 and GitHub Copilot use. That will be on the side. It should be everywhere really on the side.
Here's a structured disclaimer and some thoughts on the future applications of this tool in biomedical engineering and medical data analysis. Disclaimer. This particle motion simulation tool was developed with assistance from AI technologies, including OpenAI's GPT-4 and GitHub Copilot. These AI systems provided guidance and suggestions during the coding process. However, it's important to note that while AI contributes significantly, the final implementation, design decisions, and responsibility for the code's functionality and performance lie with the human developers. The AI systems are tools to augment the development process, not replacements for human creativity and decision-making. Future directions. Biomedical engineering applications. 1. Simulation of biological systems. The principles used in this particle simulation can be adapted to model complex biological systems, like blood flow in vessels or cellular interactions in various environments. 2. Customized prosthesis design. AI can assist in the design of prosthetics or orthopedic implants by simulating how they interact with the human body, leading to more personalized and efficient designs. 3. Drug delivery systems. Simulating the behavior of nanoparticles or other carriers in the human body can optimize the delivery of drugs to target tissues, improving efficiency and reducing side effects. Medical data analysis and review. 1. Predictive analytics. Using AI to analyze medical data can help in predicting disease trends, patient outcomes, and treatment efficacy, leading to more informed decision-making in
Just talking rubbish. The prompt wasn't great. Yeah, I don't think we have the updated code. Might update the code for a sec. It would be nice to tie this to EEG actually. Have different channels, the number of particles for each channel. Yeah, that's what I was trying to get at, not the general stuff. Yes, we actually can use it that way. I do actually have a gear which I can record EEG. Let me know if I should undust it. Try it again. It might be a while to set up. It's a bit prototypey. But yes, you can have your number of channels and the speed could correspond to frequency, which no, it doesn't at the moment. The sound being generated is corresponding to the... So first of all, each particle is its own note. Yeah, try different note scales. Currently we're using, supposedly, I think it's wrong, D major. So notes between D4 and C5. And there is not the correct amount, so some of the notes, you know, as you keep adding them, I think will get repeated. The speed is currently just set manually. Yes, you could tie it to EEG or something. Yeah, so EEG review doesn't have to be this, you know, old school stuff like this. We wanna develop some new ways to review EEG. Yeah, so even though it's time series data, you can review it in a different way. It doesn't have to be. So as you scroll through the file, as more EEG coming in, you can just update that. This tool is a bit heavy. You can hear my CPU. Yeah, and it has an error in it as well. It's loading in a certain way, and then the CSS, the styling, is applied after like 10, 20, 20 seconds or so, which is not great. Yeah, this is a more kind of standard ECG review. Yeah, you can group by left and right or overlay them all, which can be useful. In this case, you only have 16. Yeah, the separation won't work in this case. A group by side. Yeah, separation won't work as well. It only works for off. And then you can decide what your separation level is. This is a seizure. Yeah, an evolution of a seizure. And then quiet after the seizure ends. And this is 16 implanted channels that are available in the public domain. They available on IEEG.org. I think just a simple registration and you got yourself the data. There was an old Kaggle competition using that data. Anyway, so I'm just saying you could convert something like this to that. Essentially, when you have a seizure, the frequency goes up, so then the speed can go up like that. So you can essentially see and hear a seizure in a different way. We do have a tool that allows you to listen to seizure, an EEG to music converter. But yes, someone was saying that it's not real, essentially. Yeah, but that there is some not fancy, but there is a remapping to musical notes, and that's therefore to specialists this might sound a bit odd, because normally they don't do this remapping to music. They just keep it at the frequencies. So for example, if I'm playing 4 notes, I'll be just doing these exact frequencies, converting them directly to sound. But it sounds horrible, so it's okay to review for a couple seconds, but you won't be actually sitting there listening to it when you have to review very long periods of time. Yeah, so still testing this one, and hopefully it will can make it available for you to play with and watch more ads on this site. Yeah, I'll just add the more description. There's some, this is currently wrong. It's actually I need to rewrite the description. Are we using that disclaimer? well, we need to change it a bit. This is how we use Copilot for simple. It's good for simple tasks. Convert text to HTML. It's good at doing those specific things. Human developer. The labels instruction for users. Yeah, we need a H2 label in there. It's not completing the right. That sounds legit. What else we got? Yeah, those future directions are not right. Start another chat. Hey, this is also wrong. So I can't read. I have to use the board.
This is a simple particle motion simulation with collision sounds. The particles are created using JavaScript and the canvas element. The particles are given a random velocity and direction and are then updated every frame. When a particle collides with the edge of the canvas, it plays a collision sound. The number of particles and the speed of the simulation can be adjusted using the controls.
Yes, this is not quite right. That description is not quite right. Let's just load the JavaScript in it. And let's add from HTML. Yeah, we just add this. Can we write a detailed overview of this web application? Can we also write one paragraph on how to use it? Also, finally, can we write another paragraph on future directions? For example, how can we use a tool, a visualization tool like this, for reviewing EEG data that, for example, might have epileptic seizures? Yep.
Overview of the web application. This web application is an interactive particle simulation designed to demonstrate physics principles and sound synthesis in a visually engaging manner. The application utilizes HTML5, CSS, and JavaScript with the core functionality embedded within a JavaScript file. At the heart of the application are two main classes: stationary circle and particle. Stationary circle creates static circles used here to define the central stationary circle and the boundary circle. The particle class represents the moving elements within these circles, each moving with a set speed and colliding with the boundaries and each other. Key features. 1. Canvas visualization. The HTML5 canvas element is the stage where particles move and interact. 2. Dynamic particle system. Users can adjust the number of particles and their speed through sliders, affecting the system's dynamics in real time. 3. Collision physics. The particles exhibit realistic behaviors upon collisions, including bouncing off each other and the circular boundaries. 4. Sound synthesis. Unique to this application, each particle collision produces a sound, with the pitch linked to the particle's assigned frequency and the volume related to the collision's velocity. 5. Interactive controls. Users can interact with the system using sliders for particle count and speed, plus a button to restart the simulation. 6. Visual and auditory feedback. The simulation provides a combined audio-visual experience where changes in the system dynamics are immediately visible and audible. How to use the application. To use this web application, you'll interact with a canvas displaying moving particles within a circular boundary. Adjust the number of particles and their speed using the provided sliders. As the particles move and collide, they generate sounds based on their velocities and predefined frequencies. If you want to reset the simulation with new settings, just hit the Restart Simulation button. This application is user-friendly and requires no advanced knowledge to interact with and enjoy the physics and sound synthesis demonstration. Future directions. EEG data visualization and analysis. Envisioning future directions. This particle simulation framework could be adapted for more complex and meaningful applications, such as visualizing and analyzing EEG, electroencephalography data, particularly in the context of neurological conditions like epilepsy. For instance, imagine using a similar particle system where each particle represents a different EEG data point or channel. Movements and collisions of particles could correspond to different brainwave patterns, with the color or size of particles indicating abnormalities like epileptic spikes or seizures. This could provide a dynamic, real-time representation of brain activity, making it easier for researchers and clinicians to identify and analyze patterns associated with epileptic seizures. Moreover, integrating sound synthesis could add another dimension to the analysis. Different frequencies or sound patterns could be linked to specific types of brainwaves or seizure activities, providing an auditory cue to complement the visual representation. This multisensory approach could enhance the understanding and interpretation of complex EEG data, offering a novel tool for diagnosis, research, and even patient education about their neurological conditions.
Really good. I couldn't have written anything better myself, that's for sure. So the bot is winning again. So we have a disclaimer already that we are using AI technology for both generating the code and writing the text. So currently it's only prototype, by the way. Yeah, obviously this tool is very prototypey. This is just the developed in one day yesterday. Yeah, GPT-4 actually did a better job at generating the code. Copilot seemed to be silly. Sometimes it seemed to pretend not to understand the context or something of what is it you're trying to do. It seemed to be really good at like writing a specific line of code, but I'm not sure how good it is with text. Yeah, I'm pretty sure this it's mentioning the classes, so it's pretty detailed. It will be more updated as well. We'll keep the disclaimer. Copilot convert text to HTML format. No, like now, what is it doing? This is not cool. Yeah, the implementation of the LLM is absolutely crucial. Can you convert this text into HTML? Right, this is more like it. I don't know, when you use the Control-I, it probably looking at the other code as well. I don't know why. Yeah, there might be a bit of a confusion of when sound is being actually generated, but again, it's a prototype, so we can change it later. At the moment, it's only generating when the particles hit that drum in the middle, but yeah, I'm not sure what's in the text, but we can change it later. I think it just keeps it generic at this stage. Actually, so if you're reviewing EEG with something like this, they can be just circling in a specific direction. Well, obviously clockwise. So it would be like your EEG clock or something. Should we call it EEG clock? Yes, all these tools are quite prototypey at the moment. Yeah, there is always a question of how much more do you need to, develop it, improve it before it's considered less prototypey. I would say never. It's everything is a prototype, even though it's called a product. A lot of products are prototypes. You can look at Windows. Even look at NVIDIA GPUs, for example. Yeah, for example, now I'm having lots of trouble with drivers for Linux. I mean, it's working, but then there's 10 different types supposedly optimized for various things, but it's not clear. It seems to be all again prototypey. And you have ones that have all this like new features in them and stuff, but supposedly less stable. So this is what this is. They still sell it as a product. Yeah, you can that NVIDIA software thing that does eye tracking, essentially replacement. If you can see, the eyes are there. Still testing the tool. It is available on the site. There's an option to split the view, and yeah, and then they just overlay eyes that look at the camera, so it looks like you talking with the audience, whatever. That tool is very raw, to say the least. I have some older videos on it, testing it out. It only works on Windows, I think. So now I'm on Linux. I can't even use it anymore. But even on Windows, yeah, it was pretty raw. And yes, it's supposedly free, but then you need the an expensive GPU to actually run that software. So no, it is not free. So yeah, question is fair enough, but I don't think anyone can really answer it. What's a prototype and what's an actual product? It's working really, really well. I haven't tried it on our machine though. There are questions like how many resources does it take currently? So this is running all in JavaScript. There's no backend at the moment. Yeah, if you add some EEG data for this, it will require a backend. See how we go that this one does have a backend, pretty sure. This is where the data is being pulled from, sitting on the server. So yeah, go check out those tools and you will be supporting the project that way. Because my the other thing following from the same question, if it's a prototype or not, is I don't even know how many users I can support. So currently I'm streaming, so using a lot of resources that way. But yes, I don't even know how many users I can support with this. So if you know, all of I don't know how many 10 users will go on the side together, it's using my actual CPU. So if, yeah, if you probably shouldn't give you any hints, but if you want to crash my stream, so the cardio bot, for example, if I close this page, well, not much changed. One of the CPU was used. I think I'm limiting each flat complication to a 1 or 2 CPUs. My stream is using, I think, variable frame rate. So when there's actually something, a lot of something going on the screen, the network use will probably go up. So if it's actually works that way or not. Yeah, there's a network, more network usage. That way, that's probably for using this tool. I am using it through like through the web at the moment. I should be really testing it locally when I do this. But I do want to kind of see what is it you would see. I'll close this for a sec. Yeah, we used that description already. We'll be publishing this one hopefully. How about we just do it now? Because we're actually meant to be doing this Kaggle competition, but I know this will bug me if I don't publish it. It's working pretty well. What's the web page called? And not CardioBot. We also have a Blend Altman tool That's more of a blog. Yeah, someone was asking about it. Yeah, it looks like this at the moment. This actually has the code, so it's kind of yeah, it's just a blog. Those are static images, a basic one and a more realistic blend Altman plot. And it's actually has this simple Python code in it that was used to generate these two charts. So you can just copy paste it. Some essentially general overview on the plots. So we essentially publishing both of them, or maybe that one is already published. It's already live. It's missing the images. Yeah, we can check the images, and it's already running ads. That's not good. That's not good. Oops, microphone is muted. Microphone is muted is not good, is it? I was saying need to redeploy the website, and I forgot how to do it. Did about last week or so. It should be an info text file. I'll just search for deploy. Right, that looks like it. We're not releasing any new Flask application. Hopefully we'll do one this week, later this week. So I don't think we need to restart. We can do it. Yeah, let's deploy first. The website will go. It will go down for a few seconds, like 10 seconds or so. Should be back. And the plan outbound. Yeah, now it's better. So that's what it should look like. Yeah, this disclaimer. Obviously, we can do better with this disclaimer. Can do it more like this one there. a bit more extensive. Yeah, we had an old a particle motion tool. Don't worry about it. Do we need to do Apache config test? Oops. Syntax okay. Do we need to restart Apache? I don't think so. I won't be restarting it now because the website will go down again. We don't really need that. Don't really need that. Yes, if you're interested in blind Altman plots, there is a link. And this one should be live as well. I forgot what's called particle something. Particle. Yeah, it's called particles 2. I don't know if is it large like that. What does it look like? It's scaling nicely. It's actually pretty nice. Don't remember don't remember actually doing it. What does it look like on a mobile? Yeah, this thing is not fun. So the browser is essentially preventing the music from playing. I don't know, what phone do you have? It's not always accurate, so I know. So I have my custom dimensions. Yeah, the theoretical dimensions of the phone is not actually the actual dimensions. Yeah, it's confusing like that. Yeah, it will scale quite nicely. I like it. Did it load the ad? Don't think so. Yeah, the audio. So you need to essentially interact with the page for the audio to kick in. Why is it so big like that? Yeah, we need the... Yeah, it shouldn't be so huge. Should limit the... Star CSS, the canvas. Let's go back, test it locally again. This works. No, no one knows. No, sorry, I don't know. Someone is screaming at me for not using it correctly. Yeah, don't get it. Yeah, there meant to be a delay. Delay doesn't work really well. Yeah, when loading the page. Actually meant to be doing this Kegel competition today. Yeah, I'm just trying to fix the size of this thing. It's like ginormous. I don't like it, obviously. It's okay to scale horizontally. I don't get it. It's scaling fine on mobile. No, wait. This is mobile. Anyway, I'll leave it like this for now. Hopefully it's not as bad as this one. Yeah, we'll add those to the yeah, that label is wrong. That label is wrong. Anyway, let's move on quickly. Yes, we have a tool called seizure fuzz because we applying fuzzy logic to seizures. We actually have now Git is working better. It's actually yeah, let's actually open it in the new window. Yeah, this one. So this is a Kaggle competition. It's I mean, this is loading data from it, trying to display it. Let's run. Okay, this is what the front page looks like. I don't know why it's so small. We'll fix it in a bit. You can, yeah, that one doesn't work well. You can select your It's called EEG ID. That's just how the data is stored. It's a really weird format. It's the actual competition. There's 22 more days to go. We don't worry about it. We worry about the data. So we have the 26.5 gigabyte. It's stored in this weird fashion. We're trying to display it. So currently we're loading the spectrogram data, but it's not actually updating to the corresponding EEG ID. So we need to fix that. Then we be doing some basic processing and training a fuzzy logic algorithm to do a classification. So I have a bunch of labels in this data, specifically those with different types of abnormal EEG activity. Let's get to it. So let's look at the data quickly. Yeah, that's what we have in the data, and the most important file currently is this train CSV. Can open it, look what's in it. Essentially, there's an EEG ID. So this one already works in our tool. It pulls out the corresponding. And you see that there are multiple copies of it. And there is an offset in seconds. So for example, the original one that we load by default has this 18 labels. I know they're all the same anyway. And that's interesting. 42516. Yeah, the patient. It's 604. It's table, pivot table. Should we do a pivot table? I'll do it based on, say, expert consensus. Yeah, we don't care about, well, really the expert consensus is the only useful thing in it. That should be fine. Okay, that was wrong. So we haven't selected that correctly. How do we modify the pivot table? Bum, 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 bum. Okay, we don't want to mess around with this too much. Just do a regular table. Yeah, I can freeze first row, that's handy. I could just add a regular table like in Excel. Yeah, freezing first row is handy. Anyway, we have a 6 of 4. So it should be somewhere in the beginning now. That's interesting. This one has 90 sub IDs. It's quite unusual. Okay, let's start a new chat quickly. Keep saying quickly, it's never quickly, is it? It's going as slow as. That's okay. So we have this is a Flask application. Should already actually be published as well. That's the structure of the data. Yeah, don't worry about the info. Can do the front page. Let's see, it should give a summary.
All right, I see you've got a screenshot of an EEG, electroencephalogram, data viewer, and it looks like it's part of a web application for visualizing EEG data. It's displaying a segment of EEG data with an indication of a seizure event from the electrode placement FP1. The graph shows typical seizure activity with a significant spike in the EEG readings, which is common during such neurological events. The interface seems user-friendly, with drop-down menus for selecting different EEG IDs, expert consensus, which in this case is marked as seizure, and other parameters like EEG sub-ID, electrode, and patient ID. The chart below the selection options is a visual representation of the EEG readings from the selected electrode, which can help medical professionals or researchers to analyze the brain's electrical activity. Also, the source reference at the bottom points to a dataset from a competition on Kaggle, suggesting that this tool could be used for a machine learning or data analysis project focused on classifying harmful brain activity. The code snippets included are parts of what seems to be a Flask application used to serve this EEG data visualization tool. It shows JavaScript for client-side interactivity and Python for server-side data handling, which is typical for web applications. For a detailed exploration, I'd typically run the code, but in this context, it appears to be only a part of the larger application. However, it gives a good idea of how the application is structured and operates. It fetches data, populates dropdowns, displays a chart and a spectrogram based on the EEG data, and handles user interactions to update the visualizations accordingly. The Python Flask app is the backend here, serving the data and managing the routes for the various API calls made by the front end.
Someone is asking, saying I'm interested in data analytics. Do you have suggestions what I should learn first? Well, first of all, you should go and check out bionicchaos.com, because that of course will answer all your questions. No, I'm just joking. But yeah, if you do check the website and you have any specific questions that are relevant to one of the tools, we're actually publishing more tools as we speak. Do let me know. Also, you could probably do this a machine learning, data analytics competition. It's on Kaggle. So we trying currently just to load the data. Just proven to be a bit hard because it's organized in a weird fashion. But yeah, we have the 26.4 gigabyte of data. It is sorted in this way. So currently we have why did the bot say that the code is not complete? Don't think it's read it correctly. I think it's read all of it. We have JavaScript, so we have backend in here and front end because the data is in the backend. The data is in this Parquet. The raw data is in this Parquet file, so obviously Python can happily deal with them, parse them, do whatever you need with them. So that's good. Let's clear this for a sec. Are we getting some errors? No, they are all 200s. So that's good. Okay, so I have the EEG ID, have different types of EEG. It looks like potentially spiking. It actually says LPD. LPD is one of the labels. So we have 1, 2, 3, 4, 5, 6 labels. We have experts labeling this data. You can look at the data on different EEG channels. You have the patient ID. Hopefully it's correct. I'm not actually sure. This is a back end thing. Hey, this is what we were doing last time. So the spectrogram is now displayed. Are we always displaying the same spectrogram? Well, the answer to that should be yes. What? It's not always the same. The spectrogram is displayed, determined. Spectrogram ID is used to get a corresponding Parquet file. Okay. But when we select a different EEG ID, can we print out the spectrogram ID? Can we put this? Okay, spectrogram ID is 1083. So what happens if we select? Okay, how about when selecting a different EEG ID, do we also have the updated spectrogram ID from the test CSV file? The answer to that should be no. Yeah, it does not update automatically, blah, blah, blah. Yeah, we do need to update that. Actually need to not just print it in the backend, we might wanna display it on the front page. Create a mapping between EEG ID and spectrum ID. Well, how come you don't know where it is? Already have get the spectrogram data. We haven't changed anything in the code, but I might get rid of this silly comments. I wonder if people start coding without any comments, considering most language models can explain most code these days. Calculate start, convert, fetch data. Right, this one. Yeah, that's default. Oops. Don't do that. Just get rid of the comment. Because again, we'll just have the GPT or Copilot explaining the code. Yeah, we'll leave that one, this assembling rate. So I have this JavaScript. Can we explain how the spectrogram ID is being found from the train CSV file? How is it being updated when the EEG ID is changed on the front page? Currently we seem to have it displaying the same spectrogram regardless of when the EEG ID is changed by the user. Yep.
Sure, let's break it down step by step. How the spectrogram is fetched and displayed. 1. Fetching.
Did it just do like a laughter thing?
Sure, let's break it down step by step. How the spectrogram is fetched and displayed. 1. Fetching the spectrogram data. The function fetch and display spectrogram ID, is called with a spectrogram ID. It sends a GET request to the server-side Flask app at the root/get spectrogram data/int spectrogram ID, which is expected to return JSON data for the given spectrogram ID. 2. Server-side handling. On the server, the get spectrogram data spectrogram ID function handles the request. It attempts to locate a file named spectrogramid.parquet within the train spectrograms directory. If it exists, it reads the Parquet file into a pandas data frame and then converts it to JSON format before sending it back to the client. 3. Displaying the spectrogram. Once the JSON data is returned to the fetch and display spectrogram function on the client side, it calls display spectrogram data. This function is responsible for drawing the spectrogram on a canvas element. It iterates over the frequency data and maps intensity values to grayscale colors, filling in each cell of the canvas to represent the spectrogram visually. How the spectrogram ID is found. The spectrogram ID isn't directly fetched from the train.csv file within the provided JavaScript code. Normally, you'd expect a function that, upon changing the EEG ID in the dropdown, would look up the corresponding spectrogram ID in train.csv and then call fetch and display spectrogram with the new ID. However, the code you've provided seems to hardcode the spectrogram ID, fetch and display spectrogram 6465111083, so it doesn't change based on user interaction. Updating the spectrogram. When the EEG ID is changed, to update the spectrogram when the EEG ID is changed by the user, you would need to add functionality that 1. Detects a change in the EEG ID via an event listener, which you already have set up for other elements. 2. Looks up the related spectrogram ID from the train.csv data based on the selected EEG ID. 3. Calls fetch and display spectrogram with the new spectrogram ID to fetch and display the new data. Current limitation. Currently, as mentioned above, the code does not update the spectrogram based on the EEG ID selected by the user. It always displays the same spectrogram because the spectrogram ID is hard-coded. Solution. To address this, you would add a function to fetch the related spectrogram ID whenever the EEG ID is changed. This function would 1. Fetch the related data from the server, which includes the spectrogram ID. 2. Update the client-side state with the new spectrogram ID. 3. Call fetch and display spectrogram with the new ID. This would likely require an additional endpoint on the server to provide the mapping from EEG IDs to spectrogram IDs, or could be done by adding the spectrogram ID to the related data fetched with the /getRelatedData endpoint. You would then update the event listener for the EEG ID dropdown to call this new function when the selection changes.
Okay, why don't you generate the function? Can you actually generate the necessary code so that the spectrogram is displayed correctly? Making sure it's retrieving the spectrogram ID from the test CSV that corresponds to the currently selected EEG ID. Yep. Yeah, train CSV, that's right. It's amazing how it gets all the context correctly. It can correct human mistakes. Yeah, probably humans will be making way more mistakes than the bots. I'm pretty sure we already have this line in our JavaScript code. Yes, we do. EEG ID, this value, yeah, we get the EEG ID. This one is the same. I don't know why you regenerating it. Okay, fetch update chart and update charge and fetch spectrogram ID and update. Okay, this is the new function to fetch and display the spectrogram. Okay, that comment is obviously just for me. Don't need it in the code. And here is the actual function. Data populate drop down. Data display initial data fetch. Fetch and update data chart. Okay, we can do it. Over here somewhere.
Add a new route to get the spectrogram ID for a given EEG ID from train.csv.
Okay, now Python code. Have this route. Now we're adding a new one. How many routes we currently have? 10. Why so many? Have get patient ID, get related data. It's a weird one. Should have been just yeah, I don't think we need this one. Get spectrogram data. Okay, this one is getting the spectrogram ID.
Please note that the new route, get_spectrogram_id, less than int, EEG_id greater than will fetch the first spectrogram ID associated with the given EEG id. This is based on the assumption that train.csv has a spectrogram_id column corresponding to each EEG_id. If train.csv has multiple rows with the same EEG_id, this will only fetch the spectrogram ID of the first one. If you have a different logic for selecting which spectrogram ID to use, you'll need to modify the code accordingly.
Okay, so it's working okay the first time around. When you select a different EEG ID, it's giving an error. Because like doesn't exist or what? We're getting the following error. Just to be sure, the first time around the spectrogram is loading, and I assume it's the correct one, because you obviously passed the train CSV file correctly. But then again, I'm getting an error. So when selecting a different EEG ID, something is not right. Can you check the code and update? Yep. Use a better
The error
voice.
you're encountering when changing the EEG ID, get/get spectrogram ID /3284507976 HTTP 1.1500 indicates that there's a server-side issue in the Flask route that is supposed to fetch the spectrogram ID. The 500 HTTP status code means there's an internal server error. This is likely because the route is trying to access a spectrogram ID that doesn't exist, or there is an issue with how the data is being accessed in the data frame. Let's revise the /get spectrogram ID /int EEG ID endpoint to handle cases where the EEG ID does not have a corresponding spectrogram ID in the train.csv. Here's the updated server-side Flask route to handle this case. Python at app.route /get spectrogram ID int EEG ID. Def get spectrogram ID EEG try. df equals pd.read csv opath.path train.csv. Check if the EEG ID exists in the data frame and retrieve the first instance if it does. If EEG ID and df e.values, related data equals df EEG ID equals EEG ID. Return JSONify spectrogram ID related data spectrogram D. Else, return an appropriate message if the EEG ID is not found. Return JSONify error, EEG ID not found. 404 accept exception as E. Return the actual error message. For debugging, return JSONify error *E 500. With this change, if an EEG ID that doesn't exist is requested, the server will return a 404 error with an EEG ID not found message instead of a 500 server error. This will help you diagnose issues on the client side, as the client should handle this case. For example, by not attempting to display a spectrogram if the ID is not found. Now, let's also add a check on the client-side JavaScript to handle the case when the spectrogram ID is not found. JavaScript function fetch spectrogram ID and update EEG ID. Fetch /get spectrogram ID /EEG ID. Then response equals if response.ok, throw new error, failed to fetch spectrogram ID, status, return response.json. Then data equal if data.spectrogram ID, fetch and display spectrogram, data.spectrogram ID. Else, console.error, no spectrogram ID found for the given EEG ID, EEG ID. Handle case where spectrogram ID is not found. Clear the canvas or display a message. Catch error, console.error, error. This updated function will now log an error message if the spectrogram ID is not found, and you can add additional UI handling as needed, such as clearing the spectrogram display or showing an error message to the user.
Yeah, I wasn't actually listening, but hopefully that code just works. I mean, it's a simple, something simple that doesn't work. So this is in Python. Yeah, just the error handling there. So that's good. And in JavaScript, we have fetch spectrogram ID and update. Just gonna be displaying that error on the console error. Let's try it out. So the first time we run it, there's no errors. When we select a different EEG ID, there is an error. We have it in it's failing to fetch the spectrogram ID. Yeah. Should have an example of the trend CSV. Can you focus on this one? Here is an example of the train CSV file. First 23 entries. Again, we already shared it before. Can you fix the code? I'm getting the error above. The first time around it's working okay, and we're displaying assuming correct spectrogram to begin with, but when selecting a different EEG ID, something doesn't work. Can you fix that? Yep.
it looks like the server route that fetches the spectrogram ID for a given EEG ID is failing, resulting in a 500 internal server error. To fix this, we should adjust the /get spectrogram ID EEG ID route to correctly handle cases when a corresponding spectrogram ID is not found in the train.csv file. Additionally, we need to make sure that the Flask server is not encountering any other issues that would cause an internal server error. Here's the corrected Flask route, /get spectrogram ID int EEG ID, Python at app.route /get spectrogram ID /int EEG ID.
Why it's reading the code, the text-to-speech. The one I have inbuilt in the browser doesn't. So what did it actually change? So in Python, just added more error handling, I imagine.
Return the spectrogram _id associated with the first entry for the EEG _id. If the EEG _id is not found, it returns a 404 not found status with a helpful message. Log the exception and return a 500 internal server error status if any other error occurs. This error handling will ensure that the Flask route properly communicates what went wrong to the client side, making debugging much easier. The int spectrogram _id is used to ensure the JSON serialization doesn't encounter issues with data types. After adjusting the Flask route, ensure that the client-side JavaScript can handle different server responses correctly. In particular, make sure that fetch spectrogram id and update handles the case when the server responds with a 404 not found status, indicating that there's no spectrogram _id for the selected EEG _id. Here is an example.
It's just, sorry, so this voice obviously not as good as the one from OpenAI. But I have more control over it. Yes, we'll review the client side. Let's clear that. Right, we get the spectrogram data. It is weird, but it is there. However, question is what happens if we select a different EEG ID, and it does work. Okay, so it didn't just do more error handling, it's actually fixed the code, so that's good. So now the thing about it, so again, this code is from this Kaggle competition from Harvard Medical School, harmful brain activity classification, blah blah blah. There's prize money. It's lasting for another 22 days, but that should be plenty to win it if you are a machine learning specialist, which I'm not. So if anyone wants to team up for this one, more than happy to do so, because I do have some experience with EEG data. So currently we do have the 26.5 gigabyte downloaded on a server. It's open access, a dataset. In here, by default, when loading the page, is loading this EEG ID. Reason being, it has something that looks like a seizure, or what we used to process on another project. You can check how it looks like on different EEG channels. You can check the ECG, and this one is weird because yeah, we want this scaling correctly. Don't have anything in style CSS. It's actually called style, or normally called styles with plural. It shouldn't matter, but as long as it matches in HTML. Let me actually check if it's working. Sorry, just check if, by the way, there's a problem with patient ID and not loading correctly. It's obviously GPT-4 is better. In HTML, before we display the spectrogram, we would like to display the spectrogram ID, but we might as well do it over here. We don't need that silly comment. Patient ID. And here, is display spectrogram ID. That's actually interesting that it's suggesting that, because it is what we have in the train CSV file. VG label. No, wait a second, that's actually wrong. You're already displaying the start time. No, we don't need a submit. We have the offset in seconds. Display a spectrogram. And the spectrogram label offset in seconds. So what the label ID actually means, an ID for the patient who donated the data, that's patient ID, label ID, an ID for this, an ID for this set of labels. What? Doesn't make any sense. But okay. Okay, let's do one at a time. Yeah, I'll need some explanation for this HTML page as well before we publish the tool and make it available for you. Yeah, the code is not super large, so it's like medium size. I added some new outputs in the HTML, specifically the spectrogram ID and the spectrogram label offset in seconds. I would like to actually populate them. The spectrogram ID we should already have from the backend. We just want to display it on the front panel of what this should correspond to the current spectrogram that's being displayed on the screen. And it should update as well when a different EEG ID is selected. Now each spectrogram also has a label offset in seconds. We need to figure out how to display it as well. Can you prototype something and update the code? Yep. By the way, in the side note, we're streaming on LinkedIn, YouTube, Facebook, and Twitch. On Twitch, we always have like one viewer. On YouTube, we have a couple, and a couple more on LinkedIn. Facebook is nothing because I just started using Facebook as well. But this is kind of low priority. By the way, if you want to go live as well, we can bring you live using Zoom. If you don't like using the text chat in any of the platforms, can let me know. I can bring you up on Zoom. You can also talk about what is it you are doing. And if you haven't checked Bionic Chaos yet, please do so. There's a lot of tools that you might be interested in, at least one of them, I'm sure. And don't forget to let me know what you think. And currently, we're also adding a bunch of new ones. yeah, the search it doesn't really work, but you can have to remember the names. I haven't actually I'll put links to them on the front page. Yeah, we actually have a privacy page you need it for the advertisement thing. We also have particles. I know it kind of just looks silly and not relevant, but actually later we would be turning this into a different way to review EEG waveforms. So for example, if you had seizures like we do have, say, in this example, then the speed could be mapped to frequency. Each channel has its own note, a musical note. The number of particles will be the number of channels. Like over here you have 20 of them. So you will have 20 particles like this. And once you having a seizure, so if this was showing this data over time, so you will see all the channels. And if there is a seizure, during seizure it will start going like this and then slow down again after the seizure. You can have each channel like in a different color or a different musical note, which we currently have. So this is just a prototype for something like that, which is also available on the site, but there's no link to it on the front page yet. Then there's also another type of, someone was asking about it actually. Yeah, we do like ads like that are relevant to medical field. This is a blend Altman plot. And this is just a blog, it's not dynamic, it's just a static page, which is not ideal, but that's where we start from. And then you have those examples of blend Altman plot, and you also have the actual code, Python code that used to generate these two images. And yes, GPT was used. Need to expand on that disclaimer. Someone wants to join in, can set up a Zoom room. I'll put it in the chat if you just want to jump live. That's and talk in real time. In this case, potentially we could review seizures in a different way. Yeah, you could map speed to frequency. Yeah, I have to think about how to do it exactly. Yeah, I have to check how is this how the spectrograms actually being displayed. There might be something wrong. Those are not images, those are Parquet files. I'm still not displaying the spectrogram ID. Yeah, kind of trust GPT-4 better. GPT-4 clear.
To accomplish the tasks you described, we will need to update both the Flask backend and the JavaScript frontend. Flask backend. First, let's update the Flask backend to serve the necessary data for the new dropdowns. We will modify the /getRelatedData route to include spectrogram ID and spectrogram label offset seconds. Python at app.route/getRelatedData, def getRelatedData, EEG ID equals request.args.getEEG ID, sub ID equals request.args.get sub ID. If not EEG ID or not sub ID, return JSONify error, missing EEG ID or sub ID. 400 try, df equals pd.reads CSV, os.path train.csv, related data equals df did, df ZD equal int sub id. ilock 0, return JSONify, expert consensus, related data consensus, patient ID, int related data, spectrogram ID, int related data spectrum ID, spectrogram label offset seconds, int related data spectrogram label offset seconds. Exception as E, return JSONify, error star E, 500. Next, let's update the JavaScript to populate the new dropdowns and handle the updates when the EEG ID changes. First, modify the update related data function to populate the spectrogram ID and spectrogram label offset seconds dropdowns. JavaScript function update related data EEG ID sub ID. If EEG ID and sub ID, fetch get related data EEG ID and sub ID. Then response equals. If response.ok, return response.json. Else, throw new error, failed to fetch related data. Data, document get element expert consensus, value equals data.expert consensus. Document get element by ID patient ID, values data.patient ID. Document get element by ID.
Okay. It's just, I don't know why it's even reading the whole code. It's a bit odd. We updated get related data in the front end. Okay, update the related data and it takes EEG ID and sub ID as input. That sounds legit. Hopefully the IDs are correct. Can actually test in a second. Is it correct? It is. It's not being updated.
You may need to create additional dropdowns or displays for the new data as well. Here is an example of how to populate a dropdown.
Do have it. Why do I need a
Finally, call this function within the update related data function after fetching the data. With these changes, when a different EEG ID is selected, the spectrogram ID and spectrogram label offset seconds dropdowns will update to show the correct values corresponding to the currently displayed spectrogram. Remember to call the function to update the chart display after updating the dropdowns to ensure that the display is in sync with the selected data.
A spectrogram ID dropdown is currently not showing anything and not updating. Yep. Anyone wants to join me live, I'm trying to share the Zoom room link. For some reason, having trouble doing it. Specifically on LinkedIn. Okay, let's get back to it quickly. I'm trying to make this so this is data from this Kaggle competition. You can go check it out if anyone wants to team up. Let me know as well. Just trying to display the data. The default one is this EEG ID that seems to have a seizure in it. And you can't really see it in the spectrogram. I'm wondering if there's something wrong with the way it's being plotted. Also need to populate the spectrogram ID to make sure it's the correct one, and the label offset, because in this case there are 18 labels, most of them overlap, so I don't know why there's so many. Bit of a data fudging there. It's an example of how to load the normal size data set into big data. You just replicate a lot of the stuff. I think GPT might have stuffed up our code. I'm not certain. This will be in yeah, I'm still on JavaScript. There's a problem with this bit. It's shorter. I'm pretty sure something will be missing. this one was better. It was actually displaying the spectrogram. The spectrogram is in Parquet files. I have the structure for it. I don't think we're parsing it correctly. There should be 4 of them. So this is an example of the, not example, this is the train CSV. It's kind of stuff we have in it. All the labels. There's some example. Yes, there should be 4 of these spectrograms. But we get more. I don't know why. Yeah, we're not passing them correctly. If anyone wants to join live to discuss this dataset, that competition or whatever it's called. Yeah, I've shared my Zoom. For some reason I'm not able to do it in the LinkedIn chat. I just copy paste it from YouTube. Yeah, now I should see the Zoom link in the chat. It's super weird how LinkedIn works. Okay, we still have the spectrogram ID is not being displayed correctly, I think. If we can fix it in the code, that would be great. Another thing we need to check is that the spectrogram Parquet file is being parsed correctly. So above is a sample from the file. And its timing not matching the raw EEG. So the spectrogram is 10 minutes and the EEG is 50 seconds or more. Well, it should be 50 seconds. So we need to sort out how we display it all properly. Yeah, I need a proper explanation of what the Parquet file for the spectrogram is. Yeah, this bit is important.
To display the spectrogram ID correctly and ensure the EEG and spectrogram data are in sync, we need to adjust the code to fetch and display the appropriate spectrogram based on the EEG data timeframe. First, ensure the get-related data route in your Flask application is correctly returning the spectrogram ID and spectrogram label offset seconds. This information will be used to fetch the correct spectrogram Parquet file and display it. Then, you'll need to handle the timing difference between the EEG and spectrogram data. Since the EEG data is over a different time frame than the spectrogram data, you might want to display a specific segment of the spectrogram corresponding to the EEG time frame. Here is the proposed approach to address the issue. 1. Update the Flask route to return additional information if needed, for example, the length of time that the spectrogram data covers. 2. In the front end, use the spectrogram label offset seconds to determine which segment of the spectrogram to display. If the EEG data covers 50 seconds, calculate the segment of the spectrogram data that aligns with the EEG data's time frame. 3. Update the spectrogram display function to only display the relevant segment of the spectrogram. Here's a snippet on how you might modify the spectrogram display function. JavaScript. Assuming the spectrogram is over 10 minutes, 600 seconds, and EEG data is 50 seconds, function displays spectrogram segment, spectrogram data, EEG duration. Const canvas document get element by ID spectrogram canvas. If canvas, return. Const ctxls canvas.get context 2D. Const canvas width canvas.width. Const canvas height equals canvas.height. ctx.clearrect 0 canvas width canvas height. Calculate start.
I don't know why it's reading the code.
To call this function, you need to know the start time of the EEG data, EEG start time, and its duration, EEG duration. You'll have to fetch these details from the back end or calculate them based on user interactions.
Yeah, we do have data.
This is a high-level idea. You will need to adjust the code to fit into your application logic, ensuring that EEG start time and EEG duration are correctly calculated based on the EEG data being viewed. Also, the back-end route might need to be adjusted to handle this logic and serve the right data segment.
The spectrogram files are stored in a Parquet format, which is a columnar storage file format. This means that each column of the data is stored separately, allowing for efficient data compression and encoding schemes. Parquet files are especially efficient for complex data structures because they support nested data, such as lists and maps, and because they allow for efficient data compression and decompression operations. Here's an overview of how you might parse these files in a Python Flask application. 1. Reading Parquet files. You can use libraries like Pandas or PyArrow to read Parquet files in Python. These libraries support direct reading of Parquet files into data frame objects, which are table-like data structures similar to SQL tables or Excel spreadsheets. 2. Extracting data for display. Once you have read the Parquet file into a data frame, you can process it to extract the necessary information for display. If you're displaying a spectrogram, you'd be interested in columns that represent frequency bands for each electrode region: LL, RL, LP, RP. 3. Serving to front end. After extracting and potentially processing the data, like selecting a specific time range, you'd convert the data frame to a JSON format that can be easily handled by the front end for display. This is often done using the T2JSON method in Pandas, which will serialize the data frame to a JSON string. 4. Visualization. On the front end, you would then take this JSON data and use it to plot the spectrogram using a JavaScript library that can render visualizations like chart.js or D3.js. The JSON data would typically include time as one of the axes and the frequency intensity as the value to plot. Let's break down the steps in more detail. Backend Flask application.
Can we focus on how the spectrogram Parquet file is being passed and displayed, and also make sure that the spectrogram ID and the spectrogram label offset seconds are being retrieved from the train CSV file correctly and displayed on the front page. They're meant to be for spectrograms display. As explained above. Yep.
All right, let's dive into how the spectrogram data is handled in your EEG Data Viewer application. Retrieving and displaying spectrogram data. Your app deals with EEG spectrogram data in the following steps. 1. Fetching spectrogram ID and label offset seconds. The application retrieves the spectrogram ID and spectrogram label offset seconds from the train.csv file. These are retrieved through the /get related data route, which returns relevant data for a given EEG ID and sub-ID. The front end uses this information to populate the respective dropdowns in the HTML. 2. Displaying spectrogram data. The fetch and display spectrogram function requests the spectrogram data from the server using the /get spectrogram data route with the spectrogram ID. The server returns the spectrogram data in a format that includes time and frequency intensity values. The display spectrogram function then uses this data to create a visual representation of the spectrogram on the canvas element. Analyzing the spectrogram data handling. Fetching and populating data. The data flow seems efficient, with each step logically following the previous. However, the populate spectrogram ID dropdown function seems to be calling /get related data, which could be redundant if the same endpoint is already used for populating other dropdowns. Consider optimizing this to reduce duplicate server calls. Visualization. The visualization step is quite crucial. The display spectrogram function takes the fetched data and visualizes it on a canvas. The function processes the data into a grid where each cell represents the intensity at a given frequency at a specific time. This is a good approach for visualizing frequency changes over time. Handling of 4 spectrograms. Your description mentions that there should be 4 spectrograms displayed corresponding to different recording regions, LL, RL, LP, RP. However, it's not entirely clear from the provided code how these 4 different regions are being handled distinctly. You might need to modify the display spectrogram function to handle these regions separately, or ensure that the data for these regions is distinctly fetched and visualized. Room for enhancements. The user interaction could be enhanced. For example, it would be beneficial to have interactive elements on the spectrogram canvas, like tooltips showing frequency and intensity at specific points. Error handling and user feedback can be improved. For instance, notifying the user when no data is available for a selected combination or when there's an error fetching data. Final thoughts. Your current implementation seems to have a solid structure for retrieving and displaying EEG spectrogram data, focusing on handling the 4 different spectrogram regions distinctly and improving user interaction would make your application more robust and user-friendly. Consider also looking into performance optimizations, especially related to data fetching and visualization rendering.
Update the get_related_data route to fetch distinct spectrogram data for each region, LL, IL, LP, RP. You might need to adjust the structure of the data in train.csv or how you query it to get these specific values.
Yes, in theory we should have all this separate canvases for the different spectrograms, which is how the raw data is being displayed. Yeah, it is some fundamental changes to the code, so we might lose what we have so far. Yeah, obviously we're having a problem with parsing. Yeah, let's display this. Four separate canvases. Changing display spectrogram. Do we need to keep this one? Probably not. I can comment that out. We already have this function. Now display spectrogram has spectrum data and region. Date related data. Yeah, we can comment this one. And that one out. Have get related data. That will be in a Python. This will obviously not work. Have region not defined, which is fair enough. We have 4 of them. Okay, what else do we need to do? Have that description. Yeah, the regions are not defined. Yeah, I suspect the GitHub Copilot would not be able to deal with this. Hey, we need to update this code. Hey, I need you to help me. The main problem currently is that the spectrograms are not being displayed at all. Yep.
It looks like the primary issue is with the fetch and display spectrogram function not correctly handling the region parameter. This parameter needs to be defined and passed correctly to the display spectrogram function to ensure each region's spectrogram is displayed properly. Here's how you can adjust the code to fix this. 1. Fix the fetch and display spectrogram function. Modify the fetch and display spectrogram function to accept a second parameter region and ensure it is used correctly within the function. JavaScript async function fetch and display spectrogram ID region, console.log fetching spectrogram for region, region with ID, spectrogram ID. Try const response equal wait fetch / get spectrogram data / spectrogram ID. If response.ok, throw new error, network response was not okay. Status code plus response.status. Const spectrogram data equals await response.json. Console.log fetched spectrogram data for region, spectrogram data, display spectrogram data, region. Catch error, console.error, error fetching spectrogram data, error. 2. Update the display spectrogram function. Modify the display spectrogram function to accept the region parameter and use it to target the correct canvas element. JavaScript function display spectrogram data, region. Const canvas equals document.getElementById. by ID.
Any idea why is it reading the code as well? It sounds the other text-to-speech tools do not do that. Okay, what do we need to change?
It looks like the primary issue is with the fetch and display spectrogram function not correctly handling the region parameter. This parameter needs to be defined and passed correctly to the display spectrogram function to ensure each region spectrogram is displayed properly. Here's how you can adjust the code to fix this.
One sec, just mute my... back in a sec.
It looks like the primary issue is with the fetch and display spectrogram function not correctly handling the region parameter. This parameter needs to be defined and passed correctly to the display spectrogram function to ensure each region's spectrogram is displayed properly. Here's how you can adjust the code to fix this. 1. Fix the fetch and display spectrogram function. Modify the fetch and display spectrogram function to accept a second parameter region and ensure it is used correctly within the function. JavaScript async function fetch and display spectrogram ID region. Console.log fetching spectrogram for region with ID, spectrogram ID. Try const response equal wait fetch / get spectrogram data / spectrogram ID. If response.ok, throw new error. Network response was not OK. Status code plus response.status. Const spectrogram data equals await response.json. Console.log fetched spectrogram data for region, spectrogram data, display spectrogram data, region. Catch error, console.error, error fetching spectrogram data, error. 2. Update the display spectrogram function. Modify the display spectrogram function to accept the region parameter and use it to target the correct canvas element. JavaScript function display spectrogram data, region. Const canvas equals document.getElementById, spectrogram canvas style region. If canvas, console.error, canvas not found for region, return. Const ctx equal canvas.getContext 2D, rest of the code. 3. Ensure HTML elements match. Make sure your HTML contains canvas elements with IDs that match the format spectrogram canvas region, where region is one of LL, RL, LP, or RP. HTML, canvas ID spectrogram canvas, canvas spectrogram canvas. Canvas spectrogram includes spectrogram canvas RP. 4. Check backend data handling. Verify that your Flask backend is correctly handling and providing spectrogram data for each region. Ensure the data includes the required frequency and intensity information for each region. 5. Test and debug. After making these changes, test the application to see if the spectrograms are being displayed correctly. Check the console for any errors and debug as needed. By implementing these changes, your application should correctly fetch and display the spectrogram data for each specified region. Ensure that the region identifiers, LL, RL, LP, RP, are consistent across both the backend and frontend. Let's troubleshoot why the spectrograms aren't being displayed in your application. Here are a few steps to take. 1. Check the network response. Open your browser's developer tools, usually F12, and go to the Network tab. Trigger the Fetch and Display Spectrogram function by changing the dropdowns in your app. Check if the requests to /get spectrogram data int spectrogram ID are successful and returning data. If there's an error or no data, this could be the root of the problem. 2. Validate data format. ensure that the spectrogram data being returned from the Flask app is in the correct format and contains the necessary information, like frequencies and intensities, for visualization. 3. Console logs. You have console logs in Fetch and Display Spectrogram. Check the browser console for any logged messages or errors when fetching spectrogram data. This could provide clues about what's going wrong. 4. Check canvas elements. Ensure that the canvas elements for displaying the spectrogram are correctly defined in your HTML with the IDs like spectrogram canvas LL. Also, make sure these elements are properly sized and visible on the page. 5. Examine the display spectrogram function. Verify that the display spectrogram function is being called with the correct parameters and that it's executing as expected. A common issue could be that the canvas context isn't being used properly, or the data isn't being mapped correctly to the visual elements. 6. Debug the display logic. Temporarily add more console logs in the display spectrogram function to track how the data is being processed. For instance, log the contents of spectrogram data, canvas width, canvas height, cell width, and cell height to ensure they are as expected. 7. Cross-check with backend data. Make sure the data structure in the Parquet files matches what your front end expects. If there's a mismatch, it could lead to rendering issues. 8. Test with static data. As a temporary measure, try passing static data, manually created dataset resembling the spectrogram data format, to display spectrogram to check if the issue is with the data fetching or with the rendering logic. The logs and the behavior you're observing suggest that there's an issue with fetching related data for the spectrograms.
Checks if EEG_id and sub_id are provided. Handles the case where no data is.
Absolutely. Let's work on fixing the issue with your /get_related_data route in Flask and make sure it handles the requests properly. Since I don't have access to your dataset or the complete server log, I'll guide you based on common practices and the information provided. Fixing /get_related_data endpoint. Based on your description, it seems like there's an issue when the endpoint tries to access or process the data. Here's a revised version of your endpoint with added error handling. Python at app.route/get_related_data, def get_related_data, EEG ID equals request.args.egid, sub-id equals request.args.get sub-id. If not EEG ID or not sub-id, return JSONify error, missing EEG ID or sub-id. 400, try df equals pd.readcsv os.path data path train.csv. Condition equals df eeg subid equals int subid. If condition.any, related data equals df condition, ilos0 return JSONify, expert consensus, related data expert consensus, patient ID, int related data patient ID. Assuming these columns exist in your CSV, spectrogram ID LL, related data.get spectrogram ID LL, spectrogram ID RL, related.get spectrogram ID RL, spectrogram ID LP, related data get spectrogram ID LP, spectrogram ID RP, related data.get spectrogram ID RP, spectrogram label offset seconds, related data.get spectrogram label offset seconds. Else, return JSONify error, data not found for the given EEG ID and sub-ID. 404, accept exception as E, app.logger.error f error in get-related data E. Return JSONify error 500. This updated code, 1, checks if EEG ID and sub-ID are provided. 2, handles the case where no data is found for the given EEG ID and sub-ID. 3, catches any exceptions during data processing and logs the error. Updating client-side JavaScript. Ensure your JavaScript correctly handles the data received from this endpoint. Particularly, you should check if the spectrogram IDs are being received and used correctly. JavaScript/existing code function update related data, EEG ID sub-ID. Fetch/get related data, EEG ID and sub-ID sub-E. Then response if response.ok, throw new error, failed to fetch related data. Return response.json. dot then data equal existing code to update drop-down values. Fetch and display spectrogram. Data.spectrogram ID LLL. Fetch and display spectrogram. Data.spectrogram ID RL. Fetch and display spectrogram. Data.spectrogram ID LP. Fetch and display spectrogram. Data.spectrogram ID RP. Catch. I understand the frustration, and I'm here to help you get this sorted out. Let's tackle the issues with your code, focusing on the problems with fetching and displaying the spectrogram data. I'll guide you through the necessary updates. 1. Fixing the route for related data. The get related data route seems to be failing when fetching data for a specific EEG ID and sub-ID. The issue might be with the way you're accessing the data from the data frame. Here's a revised version of the route. Python at app.route/getRelatedData. Def get related EEG ID equals request.args.get EEG ID. Sub-ID equals request.args.get sub-ID. If not EEG ID or not sub-ID, return JSONify error missing EEG or sub-ID. 400. Try equals pd.readcsv os.path data path bsv. Condition equals df.ae equals sub-id equals int sub-id. If condition.any, related data equals df condition, ilock 0. Return JSONify related data.todict else. Return JSONify error, data not found for the given EEG ID and sub-ID. 404, accept exception as E, app.logger.error, error in get related data E. Return JSONify error star E. 500. 2. Fixing the fetch and display spectrogram function. Ensure that the fetch and display spectrogram function correctly targets the right canvas based on the region. Here's the updated JavaScript function. JavaScript async function fetch and display spectrogram ID region. Console.log fetching spectrogram for region with ID $spectrogram ID. try const response equals await fetch get spectrogram data slash spectrogram ID. If response.ok, throw new error. Network response was not okay. Status code response.status. Const spectrogram data await response.json. Console.log, fetch spectrogram data for region, spectrogram data. Display spectrogram data, region. Catch error. Console.error, error fetching spectrogram data for region, error. And the display spectrogram function, JavaScript function display spectrogram data region. Const canvas ID equals spectrogram canvas dash region. Const canvas equals document get element by ID canvas id. If canvas, console.error, canvas with ID canvas id not found, return. Rest of your drawing logic. 3. Ensuring proper error handling and logging. Make sure that all functions, especially those fetching and processing data, have proper error handling and logging. This will help you diagnose issues faster. 4. Testing and verification. Test these changes to ensure that they address the problem. Pay close attention to the console logs and network requests in your browser's developer tools. 5. Further steps. If the issue persists, a more detailed inspection of your data structures, especially how the .parquet files are structured and how they're supposed to link with your EEG data, would be necessary. Implement these changes, and let's see how it goes. If there's still an issue, we'll dive deeper. Sure, let's focus on the key areas where your code needs refinement to ensure the spectrogram data is correctly fetched and displayed. 1. Fetching spectrogram data. Your Flask application should have the capability to fetch the correct spectrogram data. The relevant route in Flask seems correctly set up for /get spectrogram data int spectrogram ID. Ensure that this route correctly reads and returns the spectrogram data. 2. Populating spectrogram dropdowns. When an EEG ID is selected, you should fetch the related spectrogram IDs and populate the dropdowns. Make sure the route getRelatedData.EEG ID EEG ID is working as expected. It should return the IDs of the spectrograms related to the selected EEG ID. 3. Displaying spectrograms. After the spectrogram IDs are fetched, the corresponding spectrogram data should be displayed on the canvas. Your current implementation seems to be in the right direction, but ensure that the data fetched from the server is correctly parsed and displayed on the canvas. Considering your setup, here are the code snippets that need attention. #Flask route for fetching spectrogram data. Ensure this route correctly fetches and returns data from the .parquet file. Python app.route get spectrogram data /int spectrogram ID. Def get spectrogram data spectrogram ID. File path equals os.path.join data path train spectrograms f spectrogram ID parquet. If os.path.exists file path df equals pd.read parquet file path. return df.to-JSON or equal records. Else, return JSONify error, spectrogram ID not found, 404. Char JavaScript function to fetch and display spectrogram here. Ensure that the spectrogram data is correctly fetched and sent to the display function. JavaScript async function fetch and display spectrogram, spectrogram ID, region. Try const response equals await fetch / get spectrogram data / spectrogram ID. If response.ok, throw new error, network response was not okay. Const data equals await response.json, display spectrogram data region. Catch error, console.error, error fetching spectrogram data, error. Display spectrogram on canvas. Make sure the spectrogram is correctly plotted on the canvas. For simplicity, here's a basic layout. JavaScript function display spectrogram data region, const canvas equals document.getElementById spectrogram canvas $region. If canvas, return. Const ctx canvas.getContext 2D, ctx.clearRect 0, 0, canvas.width, canvas.height. Assuming data is an array of objects, each representing a row in the spectrogram data for each row, row index. Calculate the position and size of each cell. You'll need to adjust these calculations based on your actual data structure and canvas size. Const cell width equals canvas.width / data.length. Const cell height equals canvas.height - object.keys row length. Object.keys row for each key index. If key equals time, const intensity equals row key. CF fill style to intensity to color intensity. ctx.fill rect row index cell width index cell width cell height. Function intensity to color intensity / implement a function